Hey, welcome back to yet another video. So in this video, we'll be trying to solve the 11th Leetcode problem, that is container with most water. So here's a statement. You are given n a non-negative integer a1, a2 and so on, where each represents a point at a coordinate I, ai. N vertical lines are drawn such that two endpoints of the line I is at I, ai and I, 0. Find the two lines which together with the x-axis forms a container such that the container contains the most water. Okay, so now this statement might seem a bit confusing, but it's actually very simple. So what they mean is, let's say you have this bar and this bar, all right? So how do you find the volume of the bar, or say the area of the bar? You do base into height, right? So that's all they're asking you to do. So you'll be given a bunch of bars like this. You are supposed to find the two bars between which there'll be maximum area. So in this case, it's between bar 2 and the last bar. So in this case, the base is 1, 2, 3, 4, 5, 6, 7. 7 into the height, that is 7. So it is 49. So the area is 49. Now if I take for something else, it should be lower, right? Now if I take this bar and this bar, the base is 1, 2, 3, 4, 5 and the height is 8. So the answer is just 40, right? So yeah, you're supposed to mention the two bars between which there is the most area. So the example 1, 1, 1, it's 1. Then you have 4, 3, 2, 1, 4, it is 16 between 4 and 4. And yeah, so on. So yeah, now most people might think to solve this using two for loops, that is I and j loops. So one loop can stay at say the 0th index, and the other loop can go across each element of every other index to check the area. So in this case, if the I is at this bar right here, j can go to this bar, check the area, go to this bar, check the area, and so on, and it can do it for every element, right? But that is not at all efficient, and the time complexity becomes too high. So let's learn an easier way to solve this problem. Okay, so now how can we solve this? So a naive solution would be to just run double for loops like an I and j loop, and get the length of each element, right? So 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, so and so, then 1, 2, 1, 3, 1, 4, right? But that is not very efficient and not very time, I mean it consumes a lot of time first of all. So yeah, that's a bit more efficient way to do this. First, let's get the idea clear as to what we are supposed to do. So let's say we have a container, or let's say a beaker of water like this. 2 centimeter is the base and 2 centimeter is the height. What will the volume be? It will be 4 centimeter cube, right? Similarly, let's say we have something like this. Let's say we have 4 centimeter on this side, 2 centimeter on this side, and 2 centimeter on this side. Now, how will you find the volume in this case? In this case, you have to take the shortest side and multiply it by the base. So in this case, it's 2, right? Now, why we do like that is we can just cover like this, and this can form a small beaker. But if we do the same thing with the bigger side, it won't work because this whole place is empty, right? So yeah, we'll cover it with the smallest side. So the volume will again be 2 into 4, that is 4 centimeter cube. So that's a basic idea of how to solve this. So okay, we'll have three variables. We'll have longest, we'll have longest, which will help us to find our longest area. We'll have first, which will be equal to the first index, it is 0, and last, which is equal to the first, the last index, that is length of height minus 1 in this case, that is 8. Okay, so now what do we do? I'll just write down our array. our array is 1 8 6 2 5 4 8 3 7. Okay, now we have two pointers, that is one over here and one over here, right? First and last. So the first thing we'll check is which pointer is like bigger. Is 1 bigger or 7 bigger? Of course 7 is bigger than 1, right? So what do we do to find the area? To find the area, we take the smallest side and multiply it by the base. So in this case, the smallest side is 1. So we'll do 1 into, what is the base? This is the 8th index and this is the 0th index. The base is 8 minus 0, right? So it is 8 in this case. So we can just put 8 over here. So our area will be equal to 8. We'll check if longest is bigger than area. Of course 0 is not bigger than area, so we can put longest equals area. So now longest will be equal to 8. Alright, okay. And let's erase all this. Now in this particular instance 1 was smaller, right? So since 1 is smaller, we will move 1 forward. So now 1 will move from the 0th index. I mean the left pointer will move from the 0th index to the first index. Now which one is smaller? Of course 7 is smaller, right? So area equals to height, in this case 7 into base. Base is 8 minus 1, 7, which is equal to 49. So we can just put 49 over here. I mean in our longest. So our longest is equal to 49. So now here of course 7 is smaller than 8. So we'll move 7 towards the front. So the right pointer will be over here now. Now which one is smaller? Of course 3 is smaller than 8. So area equals 3 into base. Base is 7 minus 1, that is 6. It's 18. 18 is not bigger than longest. So we'll keep longest the same way. Now since 3 was smaller, we'll move the right pointer again towards the front. Now 8 and 8 both are the same height, right? So we can put area equals 8 into, what is the base? It is 6 minus 1, 5. It's equal to 40. It is still not bigger than longest, so we'll keep it the same way. But now both are same. If both are same, we will, like, what do you say? We will move the first index towards the front, okay? So in both are same also, we'll move the first index towards the front, or the first pointer I should say. Now it will come to 6. Now of course 6 is smaller than 8, so area 6 into 6 minus 2, that is 4. It is equal to 24. It is not bigger than longest, so we'll keep it the same way. Now of course 6 was smaller, so we'll move the left pointer towards the front. It's 2. Area is 2 into 6 minus 3, that is 3. It is 6. Still not longest. We'll keep it the same way. Now 2 is smaller, we'll move the left pointer towards the front. So now it will be 5 into 6 minus 4. It will be 2. So 10 is not bigger than longest, we'll keep it the same way. Now we'll move the left pointer towards the front again. So now what? Now we'll have 4 into, what is the end pointer? It's 8, 7, 6. 6 minus 0, 1, 2, 3, 4, 5. 5. So we'll have 4 as the answer. 4 is not bigger than longest, so we can keep it the same way. So from this, what did we conclude? We concluded that 49 was the biggest area we could find. So we can return 49 as the answer. So yeah, that's basically it. That is how you solve this problem. And don't mind the first and last over here. They will get updated when you move the left pointer and the right pointer. So when I move the left pointer towards the right, it moves from 0 to 1 and so on. Alright, okay. Well, don't mind that for now. So yeah, that's how you solve this problem. And let's code the solution out. Okay, let's code the whole solution out. So first we'll have longest, or let's say biggest. This will keep track of our biggest area. By default it's 0. Then first we'll keep track of our first index, it is 0. And last we'll take care of our last index. In this case it is the last index of the array. So this is our loop while first is less than last, because we don't want the first and last overlap, right? Like we need some area between them. So now if height first is less than height last, so now what should we do? We have now to find the area. Area will be equal to height first, right, because this is smaller, into last minus first. This will give us the base. Then since first is smaller, I want to keep on moving forward, so I can just put first plus equals 1. And yeah, now if I can just put else actually. Else what area will be equal to height of last into last minus first. So in this case the height last will be smaller, so I want the last index to move towards the left. So if area is more than longest, I can just say longest equals area. By this way we can find out the biggest area we have, or no, it's not actually longest, it's biggest. Biggest here as well. Okay, now we have to return biggest, right, because this will contain our biggest area. Let's run the code. Whoa, solution, or maybe it's, let's see if this works. There you go, it works. Let me submit this. There you go, it works. But why is it so slow? Let me just submit again. And there you go. I guess this is the fastest it can run. Yeah, so that's it for this video, and don't forget to like and subscribe, and I'll see you in the next one. Bye.